Okay, let's get started. Welcome, everybody. This is the virtual public information meeting for the Meade County Solar Project. I'm going to turn my camera on so you can see me. My name is Chris Killenberg. I am a Regional Development Director for Community Energy. I'm the lead developer for this project and also the main contact and will be your presenter tonight. The purpose of this meeting is to give you information about the project, give you a chance to ask questions, provide feedback. This is part of a state permitting process, which we'll talk about a little bit later. But the entire idea is to give you information and get your feedback so that we can ideally improve the project as we head forward into the permitting processes and other processes thereafter. I'm going to switch to a slide deck, and primarily I'll be walking you through some slides. For those of you on the phone, I'll try to describe what the visuals are, and I'll stop periodically throughout for questions, and we'll have questions and answers at the end. We're going to try to finish promptly at 8:30, in fairness to everybody who's on the call, but we have 90 minutes, so hopefully that's the right amount of time. Okay. For those of you who are logged on, like I said, we're going to stop periodically and you can ask questions through the microphone. For those of you who called in, you can ask questions verbally, but you can also type in a question into the interface, which is in the bottom right corner of your screen where it says ask a question. You can type in there and then your question will be shown above at the top of that panel. And if you were thinking the same thing and you like that, you can click on the little thumbs up, which will tell us that there are multiple people interested in this question. And there are others on the phone who will help me, guide me to those questions as we go along. So that's one way to ask, but like I said, we'll stop periodically and you're able to ask your questions verbally as well. So again, my name is Chris Killenberg. I am the Regional Development Director for Community Energy. Community Energy is been in the business of renewable energy for 21 years, which is a long time. Did wind projects, and then now we do solar projects. We focus on new markets where solar is new. And as you all probably know from not seeing solar, Kentucky is a relatively new solar market. We'll talk about why we're working in Kentucky now a little bit later. Our corporate headquarters is in Radnor, Pennsylvania, outside of Philadelphia. We have offices in Colorado and North Carolina. We've done a lot of projects successfully in the past. But what's important to me and what we work hard to do is to do things right, be responsive to our landowners, our neighbors, our communities, and be someone you can trust in a project that is this significant. That's our goal, and we understand we have to earn that, but that's something that's important to us. Also tonight, I have two people available to us if we have questions for them or I can't answer questions as fully as possible. Marty Marcheterre is here. He's a senior environmental planner from Copperhead Environmental Consulting. Copperhead did our general environmental studies for the site. We'll talk about that in a minute, but they've been in business also for a long time, 16 years. Their headquarters is in Paint Lake. And also joining us, Rich Kirkland from Kirkland Appraisals. Rich has been in the appraisal business for a long time as well and has developed a specialty in appraising property as it relates to the development of solar farms in the area. He did a study for the project that I'll reference, and any questions about that, we have Rich on hand who can jump in and help answer those. So the presentation outline is going to have basically 6 sections. I'm doing the introduction now. We will talk about the project itself. What is a solar farm? What it looks like, how it's built, etc. Then we'll talk about the project site, which many of you know because it's in your neighborhood. We'll talk about the permits that we're going to be receiving and how you can participate in those processes, what the project will be like during construction and operations. And then our summary will also go into a question and answer session at the end. So let's start out talking about the project itself. Meade County Solar is a proposed 40 megawatt solar farm. 40 megawatts means that on a sunny summer day at peak production, it'll produce 40 million watts of power. Over the course of the year, it will produce enough power to be equivalent to what roughly 85% of the households in all of Meade County produce. So it's a power plant, just a different kind of power plant, but it produces quite a lot of electricity. The site is located on 370 acres, which is broken into two parts, which we'll look at more closely in a minute, generally west of Flaherty, Big Spring Road, and Stith Valley Road areas. 100% of what we produce will be sold to Big Rivers Electric Corporation. Big Rivers is, of course, the supplier to Meade County Electric. The power will likely go into Meade County Electric, but certainly it goes into Big Rivers lines and anywhere that Big Rivers lines serve. And again, it's under development by Community Energy. We are the project owner and the project sponsor at this point in the project stage. So why did we come to Meade County? Last year, Big Rivers conducted a competitive bid process seeking to add solar to their portfolio of energy supply. And it's a competitive bid process. So we and a number of other companies bid into it. We bid 3 different project concepts, and they chose 2 of those, one of them in Meade County. Part of why Big Rivers was looking for additional sources in Meade County, of course, is because Nucor is coming and they'll be requiring a lot of electricity. But also Big Rivers saw the opportunity to lock in low-cost power for a long term, which is what we did with them. And one thing that's important to know is that while solar was an expensive green choice 9 years ago when I first started doing this, today it's competitive priced against any other source of electricity, coal, gas, nuclear, etc. So Big Rivers isn't doing this out of the goodness of their heart or a green agenda. They're doing this because it's a low-cost, reliable source of power and should keep rates or help keep rates stabilized over a long-term period of time for their customers. So we talk about a solar farm, and many of you have probably seen solar panels or small solar farms, but what do we really mean here? Again, it's just a different kind of power plant, and the basic building block is a solar panel. Solar panels are about 3 foot by 5 foot in dimension, and we'll talk a little bit more about their composition here in a moment, but they're a pretty simple thing. And a solar farm is just a whole lot of those all gathered together into a facility. Solar panels themselves are simple things made of solid state materials, and they've been around. The technology that we use even today has actually been around for 50 years, since the 70s. Silicon solar cells are really not much different than they were 50 years ago. They've become more efficient, so you get more power out of the same size panel than you used to, but the technology really hasn't changed much. The good part of that is we know something about how they're going to perform over a long period of time because they've already been in existence for a long period of time. Solar panels are generally made of the silicon cells in the middle that are then surrounded by an encapsulant, basically plastic, and then a glass layer on the top and an aluminum layer on the bottom, and then wires and a frame. A very simple item. None of the materials in solar farms are hazardous. There's no liquids inside the solar panels that we use. They're pretty durable. There's tempered glass on the top. Yes, a large hailstone can break them, but otherwise they're pretty durable and expected to last a long time. And generally, these kind of solar panels will produce, after 30 years, about 75% of what they did in day one. So they're also pretty durable over a long period of time. The solar farm we're proposing will use 104,000 of these solar panels, again, spread over 2 different locations. The solar panels are then mounted on a racking system. And the racking system basically starts with a post, which is like an I-beam, and that is pounded into the ground. and that's what everything else bolts to. So the pound the post in the ground, a rack is bolted to it. The solar panels are bolted to the rack. In this case, the rack is going to move. In the morning, it's going to tilt the panels to the east towards the sun. At midday, they'll be flat, and in the afternoon, it'll tilt them to the west towards the sun again. By keeping a better angle on the sun rather than having them in fixed position, we get more production out of the solar farm. So we get more production out of the same amount of land, etc. So that's called a single axis tracking system. At the end of the day, solar farms really are just equipment in a field. They're not the same as a brick and mortar development. They're not buildings and concrete and things like that. So it's really more like just a lot of equipment in a field, and simply built and simply installed. And at the end of the solar farm's life, we can unbolt everything, pull those posts out of the ground, and the ground is back to ideally roughly where it was when we started, just a field that can go back into farming or whatever use the owner chooses at that time. Within the facility, there'll be a couple pieces of equipment. One of them is called an inverter. An inverter takes the DC power that the panels produce, which is similar to what's in a car battery, and changes it into AC, which is what you want coming out of the socket in your wall in your home. So that's an inverter. The inverters have a cooling fan on them that make a noise, which we'll discuss a little bit later, but it's one of the pieces of equipment that'll be scattered around the facility. Also with the inverters will be a transformer, which will change the voltage level from a lower level to a higher level as the electricity passes through the solar farm. You're very familiar, even if you don't know it, with transformers. They're the cylindrical cans that are mounted on the power poles along pretty much every road everywhere you go. In that case, those transformers take a higher voltage and lower it before it goes into your home. Here, we're going to create a lower voltage with the solar panels and raise it up before it goes into those same power lines. So transformer just creates a certain level of voltage that matches the need. This project will include a project substation, which will be the last stop before we then connect to Big River's power lines. And the substation will be roughly 150 square, surrounded by a fence. The original picture that we had online, for any of you that might have checked that in the website, showed a substation that you're probably more familiar with, which has high structures that go up 20 feet or more and lots of wires overhead. I just didn't realize until talking to one of the neighbors to the project the other day that in this case, we're going to be going underground into our substation and underground back out of our substation, so that it actually will be what's called a low profile substation. And the maximum height is going to be something in the 12-foot range without all the extra structures up above. For those of you who might live near or travel through Stith Valley and Stith Valley Road, that's a plus, because even though it'll be well back off the road, it'll be a lot lower in height and less visible from the road and from adjacent properties. And then lastly, all of the solar panels we install will be surrounded by a security fence. And so there'll be a couple different sections that will be individually fenced. Meade County requires that fence to be 7 foot tall. We may or may not put barbed wire on top as well. And really the point of the fence is to keep people out, mostly kids, frankly. It's once a solar farm is built, there's really nothing that you could steal, that you could carry out and has any value. So it's mostly curiosity that draws people to want to get inside. And so that's what it's there for, to keep people out. You should know, though, that we do things like take schools for tours, etc. So everything inside the fence is what we call touch safe. It means you can put your hand on anything in there and you'll be fine. Anywhere that electricity inside the solar facility gets high enough, it's going to be put into a conduit and or underground. So if you really wanted to, you could dig down to it and cut your way into it and shock yourself, yes. But you could not casually bump into or touch anything that would be harmful to you. And in that sense, it's a safe facility. The security fence is really just to keep curiosity and vandalism and that sort of stuff at a minimum. So at this point, I will stop and be happy to take any questions about this part of the project from anybody who's listening in or logged in. All right. All right, if there are no questions, we'll go on to the next section. So here we're going to talk about the project site. So for those of you who aren't neighbors, the location of the project will be in the southern corner of Meade County, west of Flaherty, just north of the crossroads of Big Spring. And in the map that I'm showing here, you see where it's pointed out. For those of you on the phone, again, it's the extreme southwest corner of the project site. And the site is broken into two parts. One part will be off of Big Spring Road, and the other part will be off of Stith Valley Road. These sites are currently used for farming, and once the solar facility is finished its operations, et cetera, can be returned to farming. One of the things we tried to do, and we'll look at this in more detail in a minute, is set the solar farm well back off the road to reduce its visibility, so that it would not have as great an effect on either of the valleys. Meade County requires in their solar ordinance that we be 100 foot from any residential structure, any home. We've chosen to go 500 feet minimum, and in many cases, we're well beyond that. So we're 500 feet from any public road, any home, et cetera. And we feel that was worth doing to try to, put it as far away and minimize its view and try not to have as great an effect on the ambiance, if you will, of the two valleys. The Big Spring section is off of Big Spring Road, as I described. There'll be roughly 246 acres there. It will be part of the project. And what we're going to do, which is also required by the county, is put a double row of evergreens along the side of the solar farm that faces Big Spring Road, which, as I said before, will be 500 feet off the road. There are some sections where there exists natural vegetation. We're going to retain that. And of course, we're open to doing anything additional we can for anybody who has a concern, to make it as pleasant as we can. There'll be a single access to this section, which we on an existing road right now, that goes onto that particular farm. When we are in operation, there'll be 2 to 3 people working across both sites. So it will not be a high traffic area. During construction, it will be busy, but ultimately, once built and screened, given the distance off the road, it'll be a quiet facility that is just quietly producing electricity off on its own and not a busy place. On the Stith Valley section, here too, we're 500 feet off of all the public roads on each side and more than 500 feet from any adjacent property. Here, because we have more exposure to the road, we'll have more evergreen plantings, and then we'll retain the natural vegetation towards the center of the site. And then finally, I mentioned the substation. If, for those of you who know that part of the neighborhood at the corner of Scott Hill Farm Road and Stith Valley Road, there is a red barn up on the street. Our substation will be behind that barn by a couple hundred feet. And again, a low profile substation. So it'll be 12-foot height-ish. And the solar farm itself, the maximum height of any panel when it's tilted up will be about 10 foot. So it's a low profile facility, not high like windmills, and able to be screened at road level by evergreen plantings. So before we go into the studies we've done for the project, does anybody have any questions about the site itself? Okay. Moving forward then, in a project like this, there are lots of studies we do for lots of reasons. And among them are a series of environmental studies that we've done and were conducted by Copperhead Environmental Consulting. And they include the identification of wetlands and streams on the site that would be eligible for protection, essentially. The Army Corps of Engineers is in charge of the waters of the United States and their maintenance and protection, et cetera. So a wetland and a stream have a technical definition, and experts like Copperhead will go out and flag what they believe meets the definition of a jurisdictional aquatic feature. We'll then meet with the Corps of Engineers to see if they agree or if they modify it, add, subtract, etc., and we'll arrive at a clearly identified set of wetlands, streams, etc., on the site, of which there are not many, but either way, once identified, our plan is to avoid them. We will give them the buffer they need. We will not encroach upon them, etc. It is possible in this world to encroach upon wetlands and mitigate and go through a lot of work to replace them somewhere else. We don't do that. We simply avoid the environmental, the wetlands and streams that are on our sites. And so our preliminary design has taken that into account, both in our positioning and the layout of the panels, etc. And that will be finalized with the Corps of Engineers this summer. We also look for cultural resources. And so here, you're generally talking about historic resources, architecture, houses, cemeteries, things like that, or prehistoric resources, arrowheads, evidence of Native American communities, etc. And so Copperhead does a site survey for those and looks for the things that are clearly visible. Then also looks for signs of potential areas of disturbance where something might have been before. And then ultimately, as part of another series of studies we'll do later, they will walk a grid of the site looking for artifacts on the ground. And here too, we expect to find some. Those of you who know the area probably know there are arrowheads and things like that around. The question is, do we find some in a concentration and of quality and value that they should be protected? And if so, we will avoid that area and stay away from it. So it's a typical process for projects like these. We always go through it. We're partway through it and have identified some things so far, but that will be part of our ultimate, final design, is avoiding those resources. Next, we also have them look at habitat for threatened and endangered wildlife. There's a series of plants and animals that are known to exist in the area that are threatened and endangered and on either a federal or a state list. And so we look for those habitats and where some of these might live or could live, etc. And they've already done that. And the primary finding is that there are 3 species of bats that live in trees on or adjacent to the site. And the way to approach that is, if we were to cut any trees, and we'll cut some trees, not many, but some, you would cut those at a time of year when the bats are not roosting in those trees. That seems to be, at this point, the extent of the threatened and endangered species habitat on site. But that too will be looked at again in subsequent studies in the future. Another thing we conducted is an acoustical analysis. We were asked earlier in the project by a neighbor whether the project makes noise, and I can tell you anecdotally, it doesn't. When you're at the limit of the fence, even within the fence, you just don't hear anything. But we didn't have anything technical to point to, and so we did conduct an acoustical analysis. And the way that works is, the different pieces of equipment that we have that make noise have from the manufacturer a noise level at that they're right up against them. Actually, it's usually 3 feet or 1 meter from them. The noisiest piece of equipment, if you'll remember from earlier, is that inverter, the piece of equipment that changes power from DC to AC. And when you're standing right against it, the cooling fans have the noise of a window air conditioning unit, something on that nature. As you travel away, distance from that noise dissipates. And it'll dissipate more if there's trees and hills and things like that. So we did a study of that noise level from the manufacturer and what that noise level would be at the closest residences, which are in the neighborhood of 1,000 feet away. And the closest residence would have a noise level, I believe we came up with 37 decibels, which is somewhere between crickets and birds. And then the other residences that are further would have less of a noise level. Keep in mind, too, that noise level occurs during the day. That's when the solar farm is working, and that's when the inverters are doing their work. And so during the day, typically, the ambient noise level is higher, and the ambient noise level would be expect to be as high or higher than what we're producing. At night, when we're shut down and the world is at its quietest, we don't expect that any of that noise would be audible either. So that puts some numbers on it, but I will say from my anecdotal experience that you just don't hear anything from the perimeter of the solar farm. The other study we did was to look at how comparable situations affected the land value, the real estate value of the neighboring properties. At this point, even though the solar industry is relatively young, there are solar farms all over the country and have been out there for years, long enough to have some statistics about how the sales of properties next to solar farms compared to similar properties in the area, compared to historical values, et cetera. And so we conducted a similar study for this, and the general expectation is that it would not have a negative effect on local property values. Now, I can understand that at a gut level, you think, well, it's not as attractive perhaps as a cornfield or a soybean field. I do think the distance that we've put the solar farm away is a significant mitigating factor. But also statistically, the data says that solar farms do not have a negative impact on property values. And it's studied, a number of different ways. The key elements that drive it are some simple things to rule out hazardous materials. We don't have hazardous materials in the solar farm. There's no odor. I just described the noise. The traffic ultimately will be very small. Stigma means the positive impression of a solar farm versus a liquor store, for instance. It's really mostly about appearance. And again, we've gone to what we purposely felt was an extra step to put the solar farm further off the road so that it would have less of an impact on the visual landscape of the area. And then the final study we'll conduct is the connection to the power line. So Big Rivers is a member of a larger regional transmission network that stretches from Minnesota to Louisiana and everywhere in between. It's called MISO. And while we've worked with Big Rivers to know that the particular power line we're going to connect to, which crosses diagonally at the intersection of Scott Hill Farm Road and Stith Valley Road, that line is capable of accepting the power that we intend to produce. There is a question of what happens when it gets to the substation on either end of that line and further out into the broader system. And it's possible that once it does that, it'll overload a switch somewhere or a cable somewhere else. And so what MISO does is study that, the effect on the greater grid, if you will. If they find that there's an upgrade needed, we would pay for that upgrade because we cause it. So, as all of you are paying a power bill to somebody, it's important to know that in those situations, you're not expected to pay that. You're not going to get an extra charge in your bill for that. It falls on the project that causes the upgrade. And we are reasonably confident that there will not be significant upgrades, but it's a study that we go through that takes about a year, and we'll learn more as we head forward. So I'm going to stop there for a second and see if anybody has questions about that.
Chris, this is Glenn. We have a question from Karen. She's asking if you can confirm the height of the substation.
Yes. So again, the original substation that was depicted on the website had the typical structures in a substation, which are 20 feet tall and a bunch of posts and steel frames. And I just didn't, when I put that together, didn't remember that our intention is to come underground into our project substation and then leave underground to go over to connect to big rivers. And so that substation that we're going to build for the project will be what's called in the industry a low profile substation. It won't need the structures up high. And so therefore the equipment, et cetera, will be at most, I would say 12 feet tall, not 20 or 25 feet tall, which is a typical substation.
We have another question from Chris. Are you considering any battery storage options with this project?
We are not. So battery storage is increasingly economic and typical in projects. We do a lot of projects now that have batteries scoped into it at the beginning. Big Rivers did not specify battery storage in their competitive bid. And so it is not a current part of the scope of this project. Other questions?
That's all we have so far.
Okay. I'll move on to the next section then, and we'll talk about permitting. So there are two levels of permitting that this project will go through, a county level and a state level. The county level is relatively straightforward in that Meade County recently passed a solar ordinance, and the solar ordinance makes solar farms a permitted use in all zones within the county. So in that case, as long as you abide by their design specifications, you have the right to build a solar farm. And in this case, the design specifications are very typical and ones that we would meet anyway, but they include, as an example, a 25-foot setback of the equipment from any adjacent property line, a 100-foot setback of the equipment from any residential structure, so a home, a 7-foot tall fence, and a visual buffer that provides reasonable screening. So as I've discussed earlier, we intend to observe the 25-foot setback, certainly a 500-foot setback from any residential structure. The 7-foot tall fence may be also with barbed wire on top. And we've proposed in our plan, which is the same plan we'll show to the county and to the state, planting a visual buffer, double offset rows of evergreens that grow to an ultimate height of 15 feet, all around the sides of the solar farm that face roads or properties without any other natural visual buffer. So we are in our plan already abiding by the county requirements or exceeding them. But if you have any questions about that, you can contact the Planning and Zoning Department. Karen Gooden there is familiar with the project, and ultimately the project will go before the county for essentially a site plan review where it will be reviewed and determined that yes, we are indeed abiding by the provisions of the county ordinance. The second permitting process is with the state of Kentucky, and specifically through the Public Service Commission. And what the state of Kentucky requires is that for any generating unit, any facility of any kind that creates or has a capacity of 10 megawatts or more, they require a special review process. In our case, in this project's case, it's 40 megawatts. So it clearly checks that box. And so the process is to establish a siting board and the siting board will look at the project and consider essentially three areas. One is environmental matters that aren't automatically triggered by the state, like wetlands and cultural resources, et cetera, but much more interested in issues like noise and the impacts on adjacent property values and things like that. So they'll look at that. They'll look at the economic impact of the project, which we'll talk about here in a minute, just to understand what the pros and cons and what's the benefit of the project. And they'll also look at the impact of the project on the transmission grid, which will largely be a review of that interconnection study I described that MISO is conducting to make sure that there are no major upgrades required, or if upgrades are required, that the project's paying for it and no ratepayer is going to get stuck with that bill, if you will. The siting board is convened by the Public Service Commission, and it includes the three members of the Public Service Commission, the chairman, vice chair, and the commissioner, two members of two state government cabinets or boards, the Energy Environment Cabinet and the Economic Development Cabinet, and then two members of the local government or the local community. Typically, it's the chairman of the Planning Commission. So in the case of Meade County, that would be Chuck Hansbrough, and a resident of the county appointed by the governor. And to be honest, often the governor asks the judge executive for a recommendation, et cetera. What's important to know is there will be local representation on that board so that they'll have a chance to reflect the community's thoughts about the project. They'll know something about the area and be able to answer questions with some knowledge of what's going on. And it doesn't just go into a bureaucratic black box. There are two members of your community who will be part of that board who will be able to speak for the community. So the process takes about 9 months, and it starts with a series of obligations on the project to make the information available, which is part of what we're doing tonight. Prior to COVID, that would have been a large public meeting that we would have rented a gym or some kind of building and had 100 people there to look at slides, et cetera. Because of COVID and the restrictions on public gatherings, the Public Service Commission has broken that into three parts during this period of time. A website, which if you haven't seen, there'll be a link at the end of this, or you can contact us and we can direct you to, but it should have been in the paper and in letters that some of you might have received. So the website for information, a virtual public information meeting, which is what we're having right now. And then in between that, in-person office hours where we make ourselves available to the public to sit down face-to-face and have a private meeting, if you will, which we had last week, which were publicized, and I think we reached out to a number of people to try to make sure that they were aware. That doesn't mean that we cease to be interested in sharing information. At this point and every point forward, anybody, anywhere who has a question, anytime, I encourage you to reach out to us. My interest is getting feedback so this project can be the best project it can be. And if anybody has concerns or questions, now's a great time to bring those up so that we know how to address that and maybe come up with an idea that solves a problem. That's the public meeting phase of the project application or the siting board process. The formal application will be submitted on or about May 5th, and that will start a formal proceeding with the Public Service Commission. Your opportunity as a member of the community to be involved in that process starts on May 5th. And at that point, you have a chance to file to be an intervener, to register, to give testimony to the proceedings if you wish. So I just draw your attention to that date. It's still a couple months off, but that's when the formal application will be submitted by us. And more information about the process is on the screen here. It's also on the website. And again, call us anytime. We're happy to direct you to these sources of information. Over the course of the process, the siting board will ask us some questions. We'll answer them. They'll ask us new questions. We'll answer them. There'll be a hearing where people will get up and have a chance to give their feedback on the project, et cetera. And we anticipate that a decision will be made in the fourth quarter of this year. That's according to the timeline they established for this process. Thereafter, if anybody wished to appeal that decision, there's a process for that too. So before I go into construction, et cetera, any questions about the permitting processes? Okay. So we'll talk about construction and operations first, or now. I described before the construction. Again, this is a relatively simple thing that we're talking about building here. And you can see in this picture, and for those of you on the phone, the basic foundation, if you will, for the system is a post, an I-beam, roughly 6 or 8 inches square, that you pound into the ground. And the I-beam's purpose is not to hold heavy weight that's on top of it. It's really to keep the whole thing from lifting out of the ground in a high wind, because all these solar panels act like wings, and on a high wind, they're going to want to lift just like an airplane would. So the primary purpose of these posts is to keep the thing down in a high wind. Now, an F2 tornado is going to cause a mess, but a typical wind loads for this area, which will be designed for, it's meant to keep everything in place and not have any damage due to high winds. Solar panels themselves will be mounted on a rack that's roughly in the 5 to 6 foot height range at its center, and they'll tilt down in one direction towards the sun, such that the low end is going to be about 3 foot off the ground, and the high end 10 foot off the ground, or 9 foot off the ground, and then they'll flatten out, and then in the afternoon they'll do the opposite. So the low edge is at its extreme is going to be about 3 feet low, and that's why we want to keep the grass tidy, because we don't want the grass growing up into it. And the high end will be about 9 foot, and that tells you sort of what your visual plane would be. The construction is really a matter of lots of parts put together. It'll take about 6 to 9 months for a project of this type. We're expecting it to start sometime in 2022. And we expect there'll be about 150 construction jobs for the construction period. And the nice thing about those jobs is most of it is no experience required. Yes, we will hire local trades like electricians and earth moving and fencing, that sort of thing, but a lot of it is assembly. And therefore, able-bodied people who are looking for work, this is accessible work. It's not something that requires a skill or experience, just the ability to show up and do simple work that's described to you. Once it's operating, there'll be just a handful of people, 2 to 3 full-time is our expectation, that will primarily be doing maintenance, preventive maintenance, and mowing. So solar panels will cease to work in a field of 100,000 solar panels. It's hard to tell that one has gone out, but once in a while you'll have some storm damage, or once in a while one of the trackers won't be tracking properly. So that's what we mean by repair. Preventive maintenance would be taking care of the motors and the inverters and everything else, doing regular maintenance. There's no oil involved, but think of things like what you do for your car to just keep it going smoothly. And then mowing is, especially in the growing season, a big part of what will go on. And again, it's important for the operation that the grass stay low, and it's required by the county that the grass stay low. Generally, solar farms are neat and tidy looking places, and that's how we envision it. That's how we design it. We've left room for mowers outside our fence, that sort of thing, all with the anticipation that it really needs to be neat as a pin, and that's typically what we do. I think there was a question I saw. Why don't I answer that now? Kind of flashed up about ground cover.
Yeah, Mary asked, how will vegetation be controlled under the panels?
Got it. So physical mowing is the primary method, and what's nice, I've gone back one slide for those of you that might be on the phone, is because the panels do tilt up at one point, you have 5 or 6 feet underneath to allow a mower to get to almost everywhere. So most of the grass underneath will be mowed by a fancy but regular lawnmower. Will weed eat? There may be some areas that will get sprayed with Roundup or something like that, but that's not typical. Typical, it's mechanical mowing, just like anything else. And what's an advantage of the rotating systems like this is there is a point where you can get to every corner. There's not always a low end that you can't quite get to. Any other questions about construction or maintenance? All right, so let's talk about output. I talked about 40 megawatts and 104,000 solar panels. So in a year, this solar farm will produce 91 million kilowatt hours of electricity. And again, based on typical consumption, that's roughly equivalent to 85% of the electricity that all the households in Meade County will consume. There's not going to be a one-to-one match, and of course, you consume power at night, and we produce power in the daytime. But the total amount of power over this 370 acres is going to be equivalent to what 85% of the households in Meade County consume. So it's a pretty productive amount of space for what it does. 100% of that solar power will be produced or will be delivered to Big Rivers, and again, it's very likely that it'll go into the line, right into Meade County Electric and right into someone's house. It's also possible that it'll go 10 miles down the line somewhere else. Electricity kind of goes where it wants to when it gets up into the system. The electricity is no different than any other electricity. It's not special. The same electrons are the same as any other kind of electricity. It's just power. So let me talk a little bit about the benefits of the project. We talked about jobs. As we said, we expect about 150 jobs during the 6 to 9 month construction period. Typically, there's a general contractor that specializes in solar farms. Their foreman will have experience, but then typically they'll run a job fair locally and hire locally because it's the kind of job that doesn't make sense that people travel great distances to come to. So we expect those 150 jobs to be local jobs. And there are numbers of other solar projects going on now in Kentucky. And what we found in other markets, North Carolina is a good example, is that once solar projects started to pop up, the crews that worked on one could move to another because it wasn't too far away and could move to another. And some of those people eventually became foremen for some of the companies. Some of those people ended up working in the solar industry, doing things like I do. So because this is the very beginning of an industry that's going to grow inevitably, we think it also has value that some of the people that work on this project will be able to continue to work on other projects in the future. There'll be construction contracts locally, things that don't make sense to outsource, electrical, site work, landscape, etc. If you are in the business or know anybody who does, contact us, get us your information. We maintain a list of vendors that we pass along to the construction general contractor when the time comes. And we really try very hard to promote the use of local people as much as possible. It should be, as much as possible, a local project. During the construction period, there'll be a fair amount of local spending. So gas, food, lodging, miscellaneous equipment, etc. And so local businesses to the area and businesses that are on the roads in and out of the area during construction will see a significant amount of additional spending from the 150 workers coming back and forth from the project site. In the long term, there'll be significant tax revenue that we'll pay to Meade County. So right now, the land that we're talking about using is assessed at very low due to its agricultural use, and the amount of taxes collected is not very large at all. We will be paying many multiples of those taxes to Meade County because of the value of the solar equipment. And the nice thing about that is it doesn't come with an offset expense. So when you build a housing development, you get more taxes from the houses, but you also have schools and water and other things that offset that revenue. In this case, there's almost nothing that offsets that revenue. We don't put additional people into schools. We don't need services, water and sewer, et cetera. Hopefully, we don't need first responders very often, if at all. So it's a significant amount of taxes that would be paid to Meade County for a long period of time on land that currently is not a significant contributor to the tax revenue. And then, as I mentioned before, there are 2 to 3 full-time jobs. I wish there were more jobs associated with projects like this, but it's a simple system that doesn't take a lot. On the flip side of it, for those of you in the neighborhood, there won't be a lot of traffic once it starts to operate. 2 to 3 people here and there in pickup trucks, no more or less than the typical farm related traffic that you now know in that area. So lastly, I just say, I'm in this business because we think this is a good addition to our choices or selection of power sources. Solar is not the only thing that can power our world, and it needs to be augmented by other things. But in the last few years, it's become cost effective, and it's going to get more cost effective. And the sun rises every day. So a quote that I like is that a single hour, the amount of solar power that strikes the earth is more than the entire world consumes in a year. And projects like these are slowly getting to the point where solar can be a solid contributor to our energy needs. At the same time, it needs to be a project that is selected carefully, is cited carefully, is considerate of its neighbors, and we care about that. So I invite you tonight, tomorrow, anytime to contact us. Please reach out to us. Let us know your thoughts or concerns, and help us make this the best project it can be for Meade County. So at this point, I wanted to open up the floor to questions about any and everything, and I'm happy to do my best to answer those.
Chris, we have a question from Chad. What is the anticipated cost for this project, and who will ultimately pay that cost? Will it be community energy, Big Rivers, or passed on to customers of Meade County RECC?
Got it. So I think at this point, the anticipated cost may still be a confidential number. I'll have to check the state filings. There'll be a point in the state filings where that will be made plain. So if I may just defer that for the moment. The answer is there'll be a private investor that will pay for this. And when I say private investor, it's going to be a large company, sometimes a utility, sometimes a investment fund, but somebody who is familiar with owning and operating power generating. So in the past, the investors in our projects have included Dominion Energy, Duke Power, people like that. But it could also be an investment fund that's specifically for the purpose of owning and operating and holding, generating assets like that. No money will be required from the citizens of Meade County or the customers of Meade County Electric to fund the project. It's completely privately funded, and the power is cost competitive, so it shouldn't negatively affect rates either. So from the ratepayer's perspective, it should be a neutral event or positive because it locks in a low price over a long period of time. Other questions? One thing that is asked of me sometimes is what happens at the end of the project. So this project is envisioned to be a 30-year operating period. And so at the end, what happens? Do we just kind of wave goodbye and see you later? The answer is no. We have an obligation to each of our landowners to remove the facility and return the ground to as close as possible to how it is today before we started. We also will have an obligation to the county to present them with our decommissioning plan that is subject to their approval. So we have, a second layer of protection there. In both cases, the notion is that prior to constructing the solar farm, we'll have a third party do an analysis of the cost of removal, which will be both the cost of removal and some offset for the salvageable materials. Whatever that number is, we will either take out a bond or an insurance policy or park cash somewhere such that our landowners, our landlords, can get access to that money and pay a third party to remove the solar farm from the land if we were to just disappear. And every 5 years, that estimate is updated to make sure it's current so that our landowners, which is our first obligation, have comfort that no matter what happens, there's enough money parked somewhere that they can pay somebody, a third party, to come in and take everything away. The county cares about that too, because they don't want the landowners to kind of forget about it and blow it off. So they want to make sure that if the county has to step in, there's resources for that too. So, I described it, it's a relatively simple thing to assemble and remove, and that's true, but it does have a cost. And so our obligation, even before we start construction, is to cover that cost and keep that security up to date so that it's always there in case we don't remove the facility properly. We talked a little earlier about timelines. We are obligated to start delivering power to Big Rivers in the end of 2022, if possible. What might delay that is any interconnection study, that study of the grid that isn't completed by then. But that's the intent. So 6 to 9 months back from that, we would start construction sometime in 2022. I do not expect, other than people on site doing additional studies, I don't expect any construction of any kind to occur this year. I saw a question flash up. Glenn, what was that?
The question from Chad is, do these panels have toxins such as lead and cadmium in them, like is reported in some panels, or are these a different type of panel free of those toxins?
So they have no cadmium. They'll have a small amount of lead in that. It's got an electrical circuit box on the back, which will have solder, like every other piece of equipment in our homes that has a small amount of lead. So I can't say it doesn't have some lead in it somewhere. It will not have cadmium, which is an ingredient in a kind of solar panel called thin film. These are silicon-based panels, old style, if you will, silicon-based panels. So there's no cadmium, selenium, some of the other chemicals that you see, and there's no liquids. I think it's 90% of the materials in these solar panels are ultimately recyclable. The recyclable industry for solar panels hasn't really kicked off because there hasn't been a lot of waste yet. But we anticipate as a company, as an industry, that by the time solar panels or solar projects are starting to be retired, that there will be an active and effective recycling industry, just as we've figured out for everything else. But no, there's no hazardous materials in these solar panels. It's the most typical style, but again, an old style, a silicon-based style panel. Other questions? So again, I would urge everybody who has an interest, who has a neighbor who has an interest, has a friend, has a question, to reach out to us or look at the resources that we've provided on the website. We really just have an interest in understanding people's viewpoint on this and how to make this project better. And that doesn't end tonight. So I encourage you to contact us at any time with any questions, and we'd be very happy to talk to you. With that, unless there are other questions, I will call an end to the meeting. Anything else from anyone? Okay, well, I thank you for logging in, signing up, attending, calling in tonight, and I look forward to speaking to anybody who has an interest in the future. Good night.